Imagine a military exercise somewhere along the coast of China. The training ground does not feature the familiar scene of hundreds of soldiers running behind armored vehicles. Instead, dozens of four-legged robots move ahead of the unit. Reconnaissance drones hover above them. A little farther back, human-sized humanoid machines emerge from an armored vehicle. One robot carries ammunition. A second opens the door of a building and enters first. A third pulls out a supposedly wounded serviceman. A fourth receives data from a drone and inspects a room that the command simply does not want to send a human into. The soldiers remain behind and effectively become operators of an entire army of machines. Just a few years ago, such a scene would have looked like something from a science fiction film. But in the summer of 2026, the main question is no longer whether this is technically possible. The main question is when China will decide to demonstrate its growing power in this field. And this is where Unitree enters the picture. The Chinese company, until recently known mainly for its amusing robot dogs and videos of dancing humanoids, has unexpectedly become one of the world's most important manufacturers of physical artificial intelligence. Reuters reports that over the past year alone, Unitree sold more than 5,500 humanoids and around 18,000 quadruped robots. And on August 19th, the company went public in Shanghai, after which its market capitalization surged to roughly $50 billion. China has effectively gained a major mass producer of machines capable of running, maintaining their balance, perceiving the surrounding world, and increasingly interacting with physical objects. But the most interesting developments are happening far beyond the stock market. Unitree robots have already appeared alongside the Chinese military. Chinese state television has shown Unitree robots alongside PLA personnel, while modified B1 series quadruped robots have been demonstrated with an automatic rifle mounted on them. Unitree itself emphasizes that it develops civilian machines and does not intend them for weaponization. But there is a fundamental problem with dual-use technologies. If a robot is capable of autonomously moving through a factory, tunnel, or collapsed building, the same capability can be extremely useful on a battlefield, and China is already openly researching this concept. In February 2026, a PLA Army Group 73 unit used robots during chemical defense exercises in Fujian province. The machines were sent into potentially contaminated areas to conduct reconnaissance and locate sources of danger. Several days later, Army Group 77 conducted tests in the Gobi Desert, where robot dogs, heavy cargo drones, unmanned ground vehicles, and exoskeletons worked together. The exercises tested cargo delivery, reconnaissance, medical assistance, and casualty evacuation. In May, robots were already being integrated into room-clearing training. In other words, the PLA is not simply posing for photographs with robots. China is gradually studying exactly where a machine can replace a soldier. And then things become even more serious. China's Ministry of Defense is already publicly discussing the concept of so-called wolf robots. These are specialized combat quadrupeds. One conducts reconnaissance, another carries a combat payload, a third transports equipment and ammunition. Some versions can be equipped with grenade launchers and micro-missile systems. Chinese military sources describe them as a unified network. The robots exchange information, autonomously detect and track targets, but final authorization for an attack remains with a human. And this is where it becomes clear why the appearance of humanoids in future PLA exercises looks like a logical next step. A quadruped robot is excellent when it needs to move quickly across rough terrain, carry a load, or conduct reconnaissance. But the human world was not built for 4 legs. It was built for 2 legs and 2 arms. Stairs, doors, handles, cars, cockpits, weapons crates, warehouses, manufacturing facilities, all of these things are designed around the human body. That is precisely why a humanoid potentially becomes an entirely different class of military machine. The Unitree G1, standing around 132 centimeters tall, is already equipped with 3D LiDAR, a depth camera, and a system of dozens of powered joints. Advanced versions support dexterous hands and an additional computing platform. The full-size H1 stands around 180 centimeters tall, weighs approximately 47 kilograms, uses LiDAR and a depth camera, and is capable of moving independently across complex terrain. The H-1-2 already weighs around 70 kilograms and has significantly more advanced arms. These are still civilian research platforms, not soldiers. But the form of the machine already almost perfectly matches infrastructure designed for humans. Now imagine that the military does not need to turn such a robot into a Terminator at all. This is the biggest misconception surrounding military humanoids. The first mass-produced military humanoid will almost certainly not be a super soldier carrying a machine gun. It would be far more useful as a robot capable of carrying 2 heavy containers through a destroyed building. A robot that delivers batteries and ammunition under fire. A robot that opens a door ahead of an assault team. A robot that installs communications equipment. A bomb disposal robot. A reconnaissance robot. A robot that can operate in areas contaminated by chemicals or radiation. A robot that can be sent to inspect a tunnel, basement, or ship compartment. These are precisely the kinds of tasks China is already testing with other unmanned platforms. But there is another reason why China deserves particularly close attention right now. The country is not simply building individual robots. It is building an infrastructure for training them on a massive scale. Beijing has specialized facilities that could literally be called schools for humanoids. At one of the largest complexes, more than 100 machines spend hours repeating physical tasks, picking up objects, opening locks, sorting boxes, and working in simulated stores, homes, and production lines. At another Beijing facility, more than 120 robot models are being tested simultaneously across dozens of real-world scenarios. The center can generate more than 500 hours of training data per day and more than 150,000 hours per year. And this is far more important than any spectacular video of a robot doing a backflip. Because the main challenge for a humanoid today is no longer teaching it how to walk elegantly. The main challenge is teaching it how to understand the physical world. A human knows how hard to press a door handle, how to lift a wet box, how to step over a piece of rebar, how to maintain balance if someone suddenly pushes you from the side. For a neural network, every one of these skills requires enormous amounts of experience. That is why China is building a gigantic machine for producing that experience. And in June 2026, Chinese authorities launched a nationwide program to train humanoid robots in real-world environments. The goal is to deploy at least 10,000 humanoids in real-world application scenarios by the end of the year and create more than 100 major practical use cases. This is a civilian program focused on manufacturing, logistics, and other industries. But technologically, it is creating precisely the kind of foundation that can later be used much more broadly. The manufacturing scale is becoming even more impressive. A new Beijing production complex was initially designed to manufacture roughly 10,000 humanoids per year, with capacity expected to increase later. A longer-term roadmap for one such facility envisions 100,000 machines per year by 2028 and as many as 500,000 by 2030. This is not a military factory, and it is not a production line for robot soldiers. But this is precisely where the boundary between experimental technology and technology of strategic scale begins to disappear. In other words, China is now building a foundation that could potentially allow it to experiment not with 5 or 10 robots, but eventually with thousands or tens of thousands of machines. And scale may turn out to be China's most important weapon. For decades, the United States has created remarkably sophisticated robotic prototypes. But China has proven exceptionally good at turning expensive technology into mass-produced industrial products. We have already seen this pattern with solar panels, batteries, electric vehicles, and drones. First, the technology is expensive. Then a dozen Chinese companies emerge. Then hundreds of suppliers begin competing to produce motors, LiDAR systems, gearboxes, batteries, and cameras. Prices fall, production increases, and within a few years, a device that previously existed only as a laboratory prototype, costing hundreds of thousands of dollars, can be ordered by the thousands. Reuters provides an almost symbolic example. The technologies underlying today's high-speed quadruped robots grew in large part out of research funded by the US military, but Unitree was subsequently able to turn a similar architecture into an inexpensive mass-market product. Today, the Go 2 starts at around $1,600, while many specialized Western military robots cost many times more. And if a similar price revolution occurs with humanoids, the military equation will change completely, because a general will begin asking a very different question, not whether a robot can replace a soldier, but how many robots can I afford to lose instead of one soldier? And that is a very uncomfortable question for any military in the world. Suppose a unit is facing a building with an unknown layout. Today, a reconnaissance team would have to enter it. Every doorway is a risk. Every staircase is a risk. Every basement is a risk. Now imagine that a group of machines enters first. Small quadrupeds explore the lower level. A drone flies up the stairwell. A humanoid opens doors, moves obstacles, and deploys sensors. All of their cameras are combined into a single map that the commander can see almost in real time. A human is no longer the first object to encounter the threat. That is what could truly change warfare. But logistics could change even more dramatically. In a modern military, an enormous number of personnel never fire a weapon at all. They transport supplies, maintain equipment, load ammunition, build positions, repair machinery, and evacuate the wounded. If autonomous machines can perform some of this work, the structure of military units will begin to change. Instead of a platoon consisting of several dozen people, there could eventually be a group in which 10 service members control several dozen ground robots and drones. The commander effectively becomes not a person commanding other people, but a manager overseeing a mixed workforce of humans and artificial intelligence. China is already using terminology such as manned-unmanned coordination to describe this concept. During 2026, the PLA conducted exercises in which unmanned ground vehicles and drones were used for reconnaissance, fire guidance, obstacle breaching, and assault support. China's Ministry of Defense has also stated explicitly that unmanned systems are becoming an important component of the battlefield of the future. And that is why future exercises involving humanoid machines, whether Unitree platforms or other Chinese systems, could look completely different from what most people imagine. No one necessarily needs to line up 1,000 robots and send them marching. It would make much more sense to start with a single unit. 5 humanoids, 10 robot dogs, several dozen aerial drones, an unmanned transport vehicle, operators, and conventional infantry. Then they would be given a specific mission: reconnoiter an area, locate a simulated adversary, move through a destroyed structure, deliver supplies, and evacuate a casualty. At the next stage, the number of operators would be reduced. First, one operator controls one robot, then one person controls 4. And then a person simply gives the command, inspect the second floor, and the artificial intelligence itself determines the route and distributes the tasks among the machines. And this exact moment could become the real revolution, because 100 fully remotely controlled robots require roughly 100 operators. That is simply remotely controlled equipment. But 100 robots controlled by 5 people is already a new type of military formation. The main weapon of the future, therefore, may not be the humanoid itself. It will be software capable of connecting 1,000 different machines into a single system. One drone sees a target. The information automatically appears on the ground robot. A robot dog discovers a passage. The map is updated for the humanoids. A satellite detects a change in position. The route is recalculated. One robot is destroyed. The others automatically redistribute its task. The battlefield turns into a huge physical neural network, and China may have an extremely strong position here precisely because of the combination of industry and artificial intelligence. Reuters reported as early as 2025 that DeepSeek models were being used in Chinese military projects, including situational analysis, planning, and autonomous systems. At the same time, China is actively moving military electronics toward its own computing platforms. In other words, 2 components are developing in parallel: the brain and the body. And if they can eventually be truly integrated, the humanoid will simply become one of the physical embodiments of a large military neural network. But here we need to dispel another myth. Modern humanoids are still a very long way from becoming ideal soldiers. Yes, in the summer of 2026, Chinese robots at the World Humanoid Robot Games in Beijing are already demonstrating incredible speeds and setting athletic records. More than 2,000 robots are taking part in competitions where they run, play football, perform industrial tasks, and compete in object manipulation. But at the same time, they still fall, make mistakes, and struggle with tasks that are simple for humans. Unitree founder Wang Xingxing himself says that the real ChatGPT moment for robotics, the moment when you will be able to simply tell a machine in words to perform a new task in an unfamiliar environment, may still be several years away. His estimate ranges from roughly 2 to 10 years. On a battlefield, the problems become even more severe. Mud, rain, sand, snow, radio interference, loss of GPS, broken cameras, damaged joints, depleted batteries, smoke, darkness, false targets, cyber attacks. The Unitree H1 uses a battery of approximately 0.864 kilowatt-hours. Civilian robots today generally do not have the energy autonomy of a human being. A soldier can work for many hours, while a robot needs to be recharged or have its battery replaced. Therefore, a robot army automatically requires another army: batteries, charging stations, repair kits, and spare actuators. There is also an even more complicated problem: the decision to use weapons. A reconnaissance robot can make a mistake and fall. An armed robot can make a mistake and kill a person. That is an entirely different level of responsibility. And it is no coincidence that even the official Chinese demonstration of wolf robots emphasizes a model in which the system can independently detect and track a target, but a human makes the final decision to authorize a strike. Therefore, the near future of warfare will probably not be fully autonomous. Instead, we are likely to see a strange transitional era in which humans still make critical decisions, but are physically present less and less often at the most dangerous points of the battlefield. The soldier will remain the brain of the system. The robot will become its eyes, hands, and legs, and then the balance will gradually begin to change. And this is where the strategic question emerges. Could this revolution make China a new type of military leader? Automatically, no. America possesses enormous experience in developing autonomous systems, advanced processors, satellite infrastructure, unmanned aircraft, and a colossal defense budget. Other countries are also actively developing robotic systems, but China has an unusual advantage: the ability to produce enormous quantities of relatively inexpensive equipment. In a war of mass production, this could prove critically important. In the 20th century, military power was determined by the number of tanks, aircraft, and ships a country could produce. In the 21st century, autonomous machines may be added to that list, and then a country capable of producing 1 million robots a year could theoretically gain an advantage that would be difficult to compensate for with several thousand more sophisticated but extremely expensive Western systems. That is precisely why today's dancing Unitree robots may be far more important than they appear. A robot doing a backflip is of no use by itself on a battlefield, but to perform that backflip, the machine has to understand the position of its own body with incredible precision, instantly regulate the forces of dozens of actuators, predict its movement, and recover its balance. And that is already directly related to the ability to move through rubble, fall down, get back up, and continue carrying out a task. Robot boxing looks like entertainment, but it trains rapid movements, reactions to external forces, and balance recovery. Football looks like a show, but several machines have to see one another, understand the surrounding space, and coordinate their movements. Racing looks like sport, but it forces engineers to improve motors, batteries, and control algorithms. Perhaps this is precisely why China's largest robotics competitions are gradually transforming from scientific festivals into gigantic testing grounds for physical artificial intelligence technologies. Reuters notes that Chinese robotics games have grown over the past decade, from small competitions into a strategic national showcase and a platform for accelerating commercialization. Today, these machines sort packages. Tomorrow they may assemble cars. The day after tomorrow they may work in the aftermath of an earthquake. And some of these technologies will inevitably attract military interest. And that is precisely why the story of Unitree is now much bigger than the story of a single Chinese company. What we may be witnessing is the beginning of a new industrial competition. Not who can build the smartest robot, but who can be the first to build 10,000 robots that are smart enough. then 100,000, then 1 million. China has already publicly set a goal of putting thousands of humanoids into real-world conditions. It is building training centers, enormous data sets, and production lines for them. At the same time, its military is learning to work with robot dogs, drones, autonomous vehicles, and artificial intelligence systems. For now, an important boundary still exists between these two worlds: civilian Unitree humanoids and fully fledged robotic PLA units. But the technological distance between them is becoming smaller and smaller. And that is why the first truly large-scale Chinese military exercises involving humanoid robots, if and when they take place, could prove far more significant than yet another new tank or missile.